Hello students, in this video lecture series we'll talk about class 9 physics chapter 9. The name of the chapter is force and law of motion. Student, what is force? The external influence which can bring about change in the shape, size, position or direction of a body is called a force. Means something which can change the shape, size or position or the direction of a moving body is called a force. Force is a physical quantity. We use a unit called Newton to measure the force. SI unit of force is Newton. Student, in this chapter we'll also discuss about the laws of a motion. Newton proposed his three laws, which is known as Newton's law of motion, which describes the motion of the macroscopic bodies. Macroscopic bodies means the bodies which we see around us. So to describe the motion of all the macroscopic bodies, Newton proposed his three laws, which is famously known as Newton's law of motion. So Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. So let's briefly discuss about these laws. So first law of motion. An object continues to be in a state of rest or of uniform motion along a straight line unless acted upon by an unbalanced force. An object continues to be in a state of rest or of uniform motion along a straight line unless acted upon by an unbalanced force. Means, if a body is at rest, the body will try to remain at rest, and if the body is in motion, the body will try to remain in motion unless the state of the body is changed by applying external unbalanced force. Student, we can understand this first law of motion from our daily life observation. When we sit inside a car at rest, and when the car starts suddenly, we feel a backward jerk. So this is because when we were sitting inside the car, our body was at rest, and our body was trying to remain at rest. So when the driver gets in the car and suddenly starts the car comes in motion, but our body tries to remain at rest. So that's why we get a backward jerk. That's what the Newton first law of motion. Similarly, when we are inside a moving car and the driver suddenly applies the brakes, we get a forward jerk. Because in this case, our body is in motion. So when the driver suddenly applies the brakes, the car comes to rest, but our body tends to be in motion. So that's why we fall forward. So that's what the Newton's first law of motion. Any body which is at rest will try to remain at rest. Any body which is in motion will try to remain in motion unless that is changed by applying an external unbalanced force. That's what the first law of motion is. Now Newton's second law of motion, what does this law says? The rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of a force. So student, this Newton's second law of motion gives us a method to calculate the amount of a force applied on a body. That means if we apply the force, what is the magnitude of that force? What is the amount of a force applied on the body? So second law of motion, Newton's second law of motion helps us calculate this amount of applied force. So it states that the rate of change of momentum, I will discuss a short while later what is momentum means. If the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of a force. So according to Newton's second law of motion, the amount of force applied on a body is directly proportional to the rate of change of a momentum. That means if the momentum is changing very fast, the amount of force experienced, the amount of force exerted on the body is large. If the rate of change of momentum is less, the amount of force experienced by the body or the amount of force exerted on the body is less. So mathematically, Newton's second law of motion is written as F is equal to m times a. So mass times acceleration. This is how we calculate the force. This is the second law of motion. Now third law of motion. What does this third law says? To every action there is equal and opposite reaction, and they act on the two different bodies. That means if we apply a force to a body, the body in return gives us the equal amount of a force in opposite direction. So student, the amount of force that we apply on a body is called an action, and the equal amount of force that we get in return from the body is called a reaction. So Newton's third law of motion says, to every action there is equal and opposite reaction, and these two bodies acts on a different bodies. These two force acts on a different bodies. Now what is the meaning of this two different bodies? Say suppose this is the body. If I place this body on the tabletop, this body is exerting a force on the tabletop. That means the action is on the tabletop. Now the Newton's third law says the equal amount of force will be given in return to this body, and the direction of this force will be upward. Now student, you can see the two force. This is the action and this is the reaction. Now the action is acting on the tabletop and the reaction is acting on the block. That's what we mean by acting on two different bodies. So action and reaction. This action and reaction will always be equal. That's what the Newton's third law of motion says. Next comes student, what is inertia? It's a natural tendency of an object to resist a change in their state of rest or of uniform motion is called inertia. So everything has an inertia. What is inertia? Inertia is a natural tendency of a body to resist any kind of change in its state. Any kind of a change in its state. Now suppose a body may be at rest or the body may be in motion. So if the body is at rest, what is the state of the body? The body's state is rest. If the body is in motion, what is the state of the body? The body is in motion. The state of the body is in motion. Now the natural tendency of the body is to maintain its state. If the body is at rest, the body will try to maintain its state. The body will try to remain at rest. If the body is in motion, that means the state of body is moving, motion. So body will try to maintain its state of a motion. So this inherent tendency, the natural tendency of a body to maintain its state is called the inertia. And student, inertia depends upon the mass. More is the mass of a body, more is the inertia. Student, to understand this, let's take example. Suppose I have a stone and I have a football of the same size. If I kick both the stone and the football will fly and the stone will not. The football flies because of its less mass. Because the football have a less mass, the football have a less tendency, the football will not be able to resist the force applied on it. So that's why it flies. But because stone of the same size have a large mass, so inertia is more. So the stone resists the force applied on it and are able to maintain its state of rest. That's what the inertia is. Now student, about the mass, we know what is mass. The amount of a matter contained in the body is called a mass. Amount of matter contained in the body is called a mass. So mass is fixed. Mass never changes. Student, about the actions and reactions I have already mentioned. Action means the force exerted by a body to another body is called action. And the second body exerts equal amount of force in return to the first body. This is called a reaction. Here one example was given. Suppose if we keep an object on the tabletop, the object will apply force equal to its weight in the downward direction. So that's the action. So action is acting on the tabletop. And according to Newton's third law, the tabletop will exert equal amount of force in the upward direction. So that's what the reaction. So that's action and reaction. As we know, actions and reactions always acts on two different bodies. Student, next comes momentum. So what is momentum? The product of mass and velocity. The product of mass and velocity of a moving object is called momentum. Suppose we have a moving body. Say suppose we have a moving body. The mass of the moving body is m and this body is moving with velocity v. So what is the amount of momentum? How much is the momentum carried by this body? So momentum of this body will be mass times velocity. The product of a mass and velocity is the amount of a momentum carried by this body, and that's what the momentum. The product of mass and velocity of an object is called a momentum. So this is the symbol we use to denote the momentum P, and momentum is measured in a unit, that's a kg meter per second. Now next students, law of conservation of a momentum. What does this law says? In an isolated system, the total momentum of the system remains conserved. Now here we have a system of two bodies. The body's mass is m1, this body's mass is m2, and both the bodies were moving with velocity u1 and u2 initially before collision. Now they collide and they get separated, and after the collision they start moving at a different velocity. So this is the situation before collision and this is the situation after collision. So this law says during this collision the velocity of course changes, but one thing remains constant in this collision process, and what is it? It's a momentum. So initial momentum, how do we measure the momentum? We have studied here, momentum is mass times velocity. So this body, when initially was moving with the velocity u1, the body's momentum was m1 u1, and this body's momentum was m2 u2. So what was the total momentum before collision? It's the sum of m1 u1 and mu u2, m2 u2. So this is the initial momentum, or the momentum before collision. And now the body, after the collision, they get separated and they started moving at the velocity v1 and v2. How much is the momentum of this body after the collision? m1 v1. And what's the momentum of this body? It's m2 v2. So what is the total momentum after collision? The sum of these two momentum. So the law says before the collision, what was the total momentum? And after the collision, what's the total momentum? That momentum always remains same. That's what we mean by this law. The total momentum of the system always remains conserved. So that's the law of conservation of momentum. Okay students, in the next lecture we'll solve some of the numerical problems based on the topic that we have discussed today. So with that, we end today's discussion. Thank you.